Hello guys, welcome to Solving Solutions, the number one channel where I get solutions to all your solving problems. It's nice having you in class again today. How have you been? On today's tutorial, we are going to show you how to generate distance from stream using the digital elevation model. So the first thing to ensure is that your data set is in a projected coordinate reference system. As you can see, WGS 84 UTM zone 32 knots. So the units will be in meters, right? Good. You can see the units here in meters. Then we are going to use Saga to perform the tasks on today's tutorial. So we come to the processing toolbox, and then we have the Saga next gen. It was actually a plugin that was installed, right? So the first thing is that we need to fill them, so we can easily search for fill them. So you can see that it's under terrain analysis hydrology, and then we are using the fill sinks, right? Now, when it's up, the input is our digital elevation model. We are going to uncheck some of these analysis we don't need. We don't need flow direction. We just need to field them, right? Good. So we come here, then we save to file. Okay. So let's call this fill them. Then we save and then we run. Good. So the digital elevation model has been filled of the sink. So we can turn that off and then we use this one. The next of the tool we are going to use is the channel network and drainage basin. So we still come to the processing toolbox. We can decide to search for it. Good. So it's under terrain analysis under the Saga Next Gen tool. And then we have the channel network and drainage basins. Now, what we are going to use as our elevation is the field them, not the first one. And then the threshold, you can be maybe manipulating it, altering it to see which one will give you the best result, but the higher the better most times. Then we also have some other tools that we run, so we need to uncheck them. What we need is basically the basin, the channels rather. So we uncheck all of these other ones. We leave the we uncheck that. So we leave the channels and then we uncheck this, right? Good. So basically what we need is the channels. So we save to file. So let's call this the channel, right? Good. So it's actually a shapefile by default as it came up, and then we click on save. I haven't done that. We can run now. Good. So we have our results. We can turn this off and then we can see the different channels, right? Good. Now what we want to do, which is the final part of the tutorial, we want to create a buffer around these channels. Now we are supposed to have one under the Saga processing toolbox. However, it's not we can't find it, so we are going to use an alternative using the native buffer we have in QGIS. So we open that up, and then the technique we are going to use is that we are going to run as a batch process. So it depends on the number of buffer you want to generate around each of those channels, and then the buffer radius is also dependent on you, right? Good. So let's take it back to single processing. This is the buffer radius, and then this is if you want to dissolve the results, which we are going to dissolve. So the parameters here will be duplicated to the number of buffer we need around each of the channels, right? Good. And then the unit is actually in meters, which is very important. So we come back to run as batch processing. Then let's say we need about 4 or 5. So let's add more rows. So we've added one. So okay, let's make it 5. So the input would still be the channels that have been generated. Then for the distance, we are going to make the first one 100 meters. We make the second one 200 down to the last, which should be 500, right? Good. So this will now give us different buffer zones from the fixed point, right? Then we now scroll down to this point and then we try to dissolve our results. Then for the buffer, which will be the output, we are going to use okay, let's click on it first. So let's take it to shapefile. So let's call this buffered underscore, right? And then we click on save. Now the autofill option, which will help us to identify each of them, we are going to fill with what the numbers, right? Good. So that it will be increasing automatically. So let's go with OK, and then let's check load layers on completion, right? And then we run. Good. So let's take that out. We have our result. So the number we have used, due to the underscore, you can see 1 2 3 4 5. That's the order based on the buffer radius. So we have to take this to the top so that we can see it. It's the smallest. Then we take it, try to arrange it in ascending order or thereabout. We take 4, okay, 3. Then we bring down, okay, let's take 4 up again. Good. So we now have the different buffers. Then let's see if we can also take the channel to the top, and then let's change the color to something like black, and then maybe make it about 0.5 so that it can be thick enough. Good. So you can now see the different channels and the buffer around them, right? Good. So we believe we have provided solution to this particular problem in hydrology surveying, or maybe whatever related field it will be. So we are going to see you on the next tutorial. Ensure you keep staying safe and have a fantastic time. Bye.